Okay, so hopefully everybody can see that. This is an application that I have stolen, to be honest, because a lot of it was already written. I've refactored it quite significantly, but the basic idea of how to do this was already there. Somebody had already done that, so I've credited them with that. That's great. Again, coding is a collaborative thing. Provided you credit people, provided you use the right license, you can reuse stuff. That's not a problem. This is a leaflet application that runs in your browser, but it actually is using a REST backend to get the data points. These are the data points. You can see point, description, some point, okay? Now, it's very simple. Doesn't do an awful lot at this point. But as you can see, you've got a lot of what you actually need here as an example to do what your application is going to have to do. Now, the other thing, so this is running in Azure. So this example is a Maven project. So it's actually in week 2, session 2, okay, of the project. But this I've got running in Azure. As I've talked about last week, you can set up a DNS name in Azure. Every time you turn on and off your virtual machine, it probably will get a new IP address, but the DNS name should remain the same. And so, that, sorry, I need to do it here. So that is where this is coming from, this DNS name. Now, the other thing I talked about last week, but I didn't explain, was Swagger and OpenAPI. Now, here I've got an OpenAPI UI, which is also running in that Azure server, okay? And the UI allows you to actually test your REST application. It gives you all the information you need to do that. So, for instance, here is a GET request. I can try it out and execute it. And it's just going to do a GET. And the GET that comes back is all of these points that are actually showing up on the map. So what I have done is I've added into the project Swagger, which is just what this technology is. It's called Swagger. And it automatically picks up your REST endpoints and generates this page for you. So you don't actually have to do this. This is magic that's done for you automatically. But what the page allows you to do then is for whatever REST calls you've got, you can document those REST calls so that whatever you need to do, you can actually try it out and you can send data to it and you get the response back. So that is very, very widely used as a technology for describing applications. If I go back to the first app, you can see I've also got this JSON definition. And this is the actual definition of your application's web app, okay? Now, this is used by the Swagger UI to generate that web page, but this is actually what your application is generating. It's generating this description. Now, the amazing thing about Swagger is that if you have that API doc, that JSON document, you can actually generate code from it. So if you want to create a client that's going to talk to your REST API and you don't want to just code it yourself, you can take this JSON, put it into a code generator, and it will generate the code for you in any language of your choice. So you can do it in JavaScript, you can do it in Java, whatever, and it'll generate. It'll be stubbed code, won't do very much, but it'll give you enough of the client to be able to talk to the API and just get something working. Okay, I'll probably generate unit tests for you as well as part of that. So that's what Swagger does for you. The Swagger was the original name for this technology. It was created by a company called Brown Bear, but they've open sourced that now, and it's called the open source project is called OpenAPI. And you will see that everybody from Azure, everybody uses this as a way of documenting REST APIs and of creating something that you can test the REST APIs against easily. If I'll show you my project, OpenNMS. So this is my project I work on when I'm not doing this, which is OpenNMS. And under help, under API documentation, OpenNMS has got a very extensive API, but it's basically using the same technology to document the endpoints. And it should come up in a sec, hopefully. There we go. Right. So it isn't exactly the same as look and feel, but it is basically doing the same thing. The REST API for OpenNMS is all documented here, and you can actually run the examples and try them out. It's just different styling, basically, but it's exactly the same technology. It's using Swagger under the hood to do this. So that's a real project that does this sort of stuff. And you'll see similar stuff, when you use the REST API in Azure or anything like that. It's all documented using OpenAPI because it makes it easy for people to generate code, to actually try out an API. So that's enough of that. So I'll go back to the map app. As you can see, it's very simple. This is the one that's running on my local machine rather than running in Azure. Again, I've just spun this up, using Docker in my local machine. But it's the same idea. Okay, any questions on that before I go any further? Okay, good. Right, so I need to show you how this works. What I need to do is, it may be easier, I don't know if it's easier to go through the code here or it's easier to go through it on GitHub. I'll try going through it here. So this is session 2. I'm actually going to pull this in as a Maven project. I'm using Eclipse. Other IDs are available. What's happened? Maybe somewhere else in my project. Okay, never worry. Okay, so sorry about that. It's a bit strange. I wanted to actually show you it more as a Java project. Anyway, the key thing is that if I go actually to GitHub and look at it there. So this is session 2, Spring Boot Leaflet Starter. And I go under the source code and look under the main. You'll see that there's Java code here, and then there's also this web app. Now, under the web app, under the view, there is a JSP, okay? And that JSP basically is the thing that renders up the leaflet application, all right? All these words down at the bottom here that are showing up in the app are just coming out as standard JSP. But really, all this does is it pulls in leaflet. You can see there's a view, map.js is the actual leaflet code it's pulling in. And there's a few other things it's pulling in. To be honest, go and look at the leaflet documentation, but this bit works. And you probably don't need to do very much to change it. You might need to do a bit of styling or stuff like that. But the JSP basically gives you most of what you need, and you can hack it around to get it to be what you need it to be, okay? And it just pulls in leaflet. Now, what leaflet does is it goes to known endpoints, they're the REST endpoints, and they're being generated using the Java code, okay? So that's how that works. Now, you can see that in this example, it's actually coming under web app, webinth, and view. And normally, if you were just running this as a standard JSP, like in session 1, where we did that example, if I look at how that's done here, the JSP is just placed under the web app and not put into the meta-inf. Now, the reason for the difference is that we're going to be using something called Spring MVC, Model View Controller. So when you did stuff last year with your web app, if we look at this particular JSP that I hacked about with, you can see that you're doing actual code in the page. So here we know the string f name equals, get request, get parameter, first name. So you're writing a load of code in the page. And the problem with that is that you really want to separate out the concerns of writing code from the person who's styling the page. So, if somebody comes along and they have to, do CSS and style it and make it pretty, they don't want to have to worry about upsetting somebody's code or having code being done at the same time. You want to keep the two completely separate. And the way to do that is, instead of having the code actually here in the page, you actually put it in a separate controller. And all you inject into the page is the variables that are going to render up the various things you want to have on the page. And that's what Spring MVC does, okay? So if we look at, so that was the old example. So if we look at Spring MVC, and again, the difference is that Leaflet is, this JSP is actually running under Vue. But if I look in the Java resources under controller, this page controller is what's doing the mapping. So if you saw, there was a request mapping coming in, and it's a request to, the top of the page. So, if I show you the page again, I'll explain what that means. It's 8080 /. So it's the first thing that page encounters. That's basically the index page, the first page you want to get to. And in my, sorry, go back to that. In my code, you can see that the request mapping here is mapping that /, which is the first root of the page, to this Leaflet JSP. That's just using the name Leaflet JSP. It's not actually putting JSP on the end of it, because elsewhere we tell Spring Boot that actually all of our JSPs are going to end in this name. So if I look elsewhere under resources, under application properties, you can see that Spring MVC Vue prefix, I'm going to put all of my pages in webinf/view, and all of my suffixes for those pages are going to be .jsp. So all that means is then, if I go back to my page controller, basically whenever I do a request to that /, it's going to render up that JSP. That makes sense? Okay. Now, obviously, you can have many more mappings for different pages. And the thing that we will look at next week is you can also then inject data into the page. So you can actually have your code running in this little method, and the code then creates what is effectively a hash map of a name and a value. And then in your page, you can reference the value, and it will give you reference the name, and it will give you the value in the page. So it means that your actual Java server page is much, much simpler than it would be if you had to write all the code in the page. You're just doing it here. Now, obviously, I've given a reference in the README to all of the tutorials that are in this here. Okay. So I would definitely expect you to go away and read the tutorial and try some of that out, because that will help you understand what's going on here. I will give you one example that is useful for what you're actually going to do in the project, but these other examples give you a bit more depth of knowledge of how Spring works or Spring MVC works. So go and have a look at the tutorial, try it out, see if you can get it working, see if you can learn from it. Okay. The actual application, this thing, was taken from an example. So I think further down here, I've got, where to put it? Yeah, this example here, Imaginellis Spring Boot Leaflet Starter. Now, they used something called, what's it called? I don't know what it's called. They didn't use JSPs, right? They used a different technology. So let me just click on that and we'll just see what they did actually use. In their case, if you look at the resources, they've got templates in the resources. And in their case, what they're actually using is, I've just forgotten the name of it actually, but it's a different way of doing this that Spring recommends. I've just gone from my mind, to be honest. So I took that and changed it into JSPs. So that's just so you can use something you're familiar with rather than learning something new again. But that was the example that we started with. Okay. All right. So that basically explains how the JSP works. Now we need to look at how does the REST API work. Okay, and that's a little bit more complicated. So the REST controller here is very like the page controller. So the page controller is mapping that request to a JSP, but the REST controller, where's it gone? Why can't I see that? What's gone wrong? Right, there we go, something strange. The REST controller is basically doing the same thing, but it's mapping, in this case, a /get and a /get-id, okay, to a method. And the method is going to return a response. And the response in this case, it says iterable map point, but it's basically going to be a list of map points it's going to return, okay? So what we've done here is that what we've basically created methods again, but those methods are going to, instead of returning a page, they're just going to return JSON back, which is what your REST API does. And then there's other annotations in here. So this operation annotation is not part of the REST interface. That's what Swagger uses to actually add the documentation onto the page, the Swagger page. So you can put a load of documentation in your REST API to explain what the call does, to explain what comes back and everything. And you can use these Swagger annotations to actually put that information in. But the request mapping annotation, and that is actually a Spring annotation that does the work of running the REST API. So just keep them separate in your mind. There's annotations here for generating the documentation, and there's annotations for just implementing the REST API. How are you doing? Can you find a seat, or are you just? Oh. That is a seat there, I think, yeah. Right. So does that make sense? There's obviously more to learn, but I'm just saying, this is where to look, okay? So there's two things here. There's the page controller that's going to render up the pages, and there's the REST controller that's going to render up the REST API. And obviously, the REST API for generating the points for this example is already being provided for you, but you will probably need more REST operations in order for you to be able to upload to your app the data that you need to upload, and including the latitude and longitude and that. So you're going to have to expand this REST API to do more than it does at the moment. And when you do that, you can start off by just stubbing the API. And by that, I mean, it doesn't have to do anything. It just create the method and have the method, return some random data to start with. Later on, you can wire it up to real code. But, quite often it's useful for if somebody else is working on the JavaScript side of things, then if they just have an API that just receives their data and sends something back, that's good enough for them to get on with their work. And you could generate a stubbed API and render up the Swagger stuff on that stubbed API. Again, the API doesn't work, but you've got something to test it that just allows you to see, enough to be able to do the rest of the work. And usually that's how teams work together. They create enough of the API so the other team can get on with doing their work. And then the backend guys will carry on getting their API actually functional, but they implement as much of it as they can just as a stub so that the guys who are doing the JavaScript or doing the web page have got something to work with. Okay. So that's that. Now, The next thing, of course, is where does the data come from all of this? And you'll see that we've got this map repository dot find all. So that should give you a clue. That map repository is some sort of data access object that's going to get access to the database to do its magic. And obviously the find all method is going to find all of the objects in the database and return all of them. So in this case, there's 4 points. It's going to return 4 points. Okay. So there's something that's creating that map repository. And you can see in this REST controller, it's been auto-wired into the REST controller. So that's what Spring does for you. Spring, if you have to write an application and you have to do new this, new that, and wire things up yourself, that's a huge amount of work. But what Spring does is you can put a very small number of annotations on your classes, and it will automatically spin up the class, create an instance of it, wire it up whatever way, and then any other classes that depend on that class, it will allow them to find that class. So what's happening here is, because I've annotated this with auto-wired, that map point repository is being found somewhere else and injected into this particular class, so that whenever my REST controller wants to make a call to get, it's got a map repository to make the call against to do some work. Any questions on that? Usually when people are silent, it means they're, there's too much here. Okay, well, we'll go through it again. Okay, now where does that repository come from? Well, actually, this is the object here. And magically, it's very, very simple. All it is extending an interface, in this case called JPA repository, using an object called map point and using a long. Now, in this case, what the long is the ID in the table of the database for that device. So it's 1, 2, 3, 4, or whatever. We're using a long for the ID. And the map point, if I show you that under the model, is basically the name, the description, the category, the latitude, and the longitude. So if you think about it as a database table, that is the row. And the columns are the ID, which in this case has been annotated as that's the ID. And then the description, the category, the latitude, and the longitude. Okay, these things here. So if you saw the database that's behind this, it would be a single table. The table would have all of these columns in it, and the actual table name would be map point. And these annotations you can see on this are how that actually works. So we're using a technology called JPA, Java Persistence Architecture. And again, you can go away and look this up, all right? JPA can be used standalone, in which case you have to write the data access objects. And in previous classes, I've actually taught people how to do that before I've moved on to Spring, because Spring's so easy. So it's better for you to know what Spring does. But basically what you do is any objects that you need in your database. So next week, we're going to look at user objects, okay? Because you're going to have to define users for this system. So there'll be a user table in the database. There'll be a user object. It'll have a username and password and a bit other information in it. In this case, the only table we've got is the map point table. And, the ID here, if I should point it out in this, right? The entity basically says, this is going to be an entity in my model, which basically means it's going to be a table in my database. ID tells it that this particular value, this long, is going to be the number or the row in the database that's going to correspond to this particular object. And then generated value says that the database is going to generate this automatically. So every time we create a new one of these, it'll be given a new number automatically. Every row is going to have a new number. Okay. And then the rest is just getters and setters. So all very simple. All right. So the repository, magic happens. It basically creates all the code you need to access the database. Right. Now I can show you what that method does, because I'm going to go and look in the Java doc for Spring. This. Right. Yeah. Go away. Come on. Right. So that's a Java job for a JPA repository. Okay. And, there are other objects that it implements, but you can see, you've got various methods like the find all method, which we saw, but you can do other things as well. Okay. There is actually a pagination version of this too that allows you to pull stuff back in pages, which, again, very useful. The CRUD repository, which this extends, if I just go to CRUD repository, has these methods, which are, delete, create, find by ID, save. Save will create the entity. So you basically, to create this, you're going to save it in, using save or save all. You can put a list of entities in. Okay. So Spring does a huge amount of work for you. What it actually does is it connects you to the database. Now, how does the database connection happen? Well, if we go back, not to that, but to this. If we go back to the actual resources in this project, you see this application.properties. And what I've done is, to get us going, I've used something called HSQLDB, which is a database that is built in Java. Okay, so I don't have to have a separate database. This is just a simple database that just runs in the virtual machine. And the URL for that data source is actually saying memory. So it's actually running in memory. So that database that we've got at the moment is just in memory. It's not saving anything anywhere. It's in memory and nowhere else. And then what we have is the username and password. And then we have what's called the JDBC driver that allows Spring to talk to that database. And, everything else really is just, simple annotations just to get the thing going. So that's how you would get this thing to work with an in-memory database. If I commented that up and used this memory, then the database would actually be in my target directory, and it would be persisted as a file called product.db. So if I wanted to use HSQLDB, and I wanted to persist the data permanently rather than have it in memory, then I would use a different URL. I couldn't use target, to be honest. I'd have to, on my machine, I'd have to find a temporary directory on my machine that can put that data in, because target is ephemeral. It's going to go away and come back again. All right. But you just put it in a directory you want it to be in. Now, that's all the magic, right? What if I wanted to use a real database? Well, here we have an example of exactly the same thing, which actually has come from the original example that I originally hacked. And this is using MySQL. So in this case, the data source URL, is JDBC, MySQL. And then, you've got, that's the URL for your MySQL database. And you could have MySQL running locally on that machine, or you could have another Docker container running MySQL, and you just link to the Docker container and magic would happen. Okay, so it's very, very flexible. You can use any database you want. The important thing is that you've got the JDBC driver on the class path. Every database has a Java driver for it. And JDBC is a Java database connector. So it doesn't matter what database you use, any respectable database will have a driver. You've just got to make sure it's on your class path, and then you reference it, and Spring will pick that up and say, okay, that's what I'm going to use. This little bit here, Hibernate DDL and Hibernate Dialect, underneath the hood, that repository is using something called Hibernate. And Hibernate is an object relational mapping framework. That sounds like a lot of complicated words. Basically what it does is it says, here's a Java object, I can map it into tables in a database. And Hibernate's one of the most widely used frameworks. Now, Hibernate needs to know what type of database it's talking to. So here, the Hibernate dialect would be MySQL. So it knows how to talk to MySQL. MySQL's SQL is different to, Microsoft's SQL. It's, so Hibernate's got lots of dialects it can use. You could use Postgres. And in this case, with, I don't even think they've actually set up the dialect for this one, to be honest. They probably didn't need it. It probably just worked out of the box without needing that dialect set up. But in this case, you did need to set it up for MySQL. Okay. So that's basically how this stuff works. Now, this map application is the class that gets it all going. And so what this basically does is, every Spring Boot application will have something like this in it, okay? We annotate it as a Spring Boot application, so whenever Spring Boot boots up, it knows what it's looking at. This extends the Spring Boot servlet initializer. Now, what happens is that when a WAR file is dropped into Jetty or Tomcat, Tomcat or Jetty will scan that WAR file and will look for a servlet initializer in that file. And every servlet initializer it finds, it says, I need to run something on this, and it will run something on that class. So this Spring Boot servlet initializer is what Jetty uses to say, I've got a Spring Boot application here. I need to spin it up. And it will use that method, and there'll be methods in there that it will call to actually get that initializer up and running so your application starts, okay? So the important thing is you have an application that has this initializer in it. And if it has that, then if it's packaged in a WAR, the WAR can be dropped into your folder and everything will work. This stuff here, this being command runner stuff, all that's doing is initializing the database with a few points. So you saw the 4 points on my map, these 4 points here. Sorry, move to that. These 4 points here, okay? Where did they come from? They came from, come on. Why are you doing this? I don't know what's going on. Yeah. Well, the problem is it's hard to. Right. Okay. So those points are being injected. All right. Now, obviously, in your application, you may have to inject some information just to get things going in the database. That's how you would do it. But what your application is going to do is actually inject new points into the database. So you're going to have to create a REST call that's going to do that, inject those new points, and inject an image. That's a bit more of a challenge, right? You have to work out how to do that. Okay, but this basically spins up and injects those points in the database and gets the thing going. Any questions on all of that?
What is the database of choice? Can we use SQLite or not?
You could if you want, but I'd prefer you to use a real database.
Because I'm assuming one wants to have it in the cloud so that we can all access it instead of having it loaded.
Yes, exactly. So, but what you'll do is you'll create a Spring container, you'll create a Docker container with a database in it. And that can be any database. You can use MySQL, you could use Postgres or something like that. You could use MySQLite, but I prefer you to use, like a real one.
Yeah, it's just we've been doing that.
I know, it's not hard. I mean, creating a Docker container, I mean, there's stacks of Docker containers for all the databases you might want, and lots of recipes for doing it. So it's actually really easy. Any other questions? Right. There's a lot there to learn. I mean, I appreciate I'm going through Lightning and it's like, when somebody stands up and says, this can easily be shown, and he skips about 20 steps. Well, that's why I've given you the tutorials to go away and look at those 20 steps, because there is a lot behind this. But I'm just giving you enough that you can hack around and get a solution out the door, which is really what engineers tend to do. They don't go into the detail. They just get enough to be able to get it to work and hope for the best right after that. Okay, so I've shown you Spring Boot. I've shown you how to get that thing going. That's just your starting point. Now what I want to do is I want to talk about how we can deploy this stuff in Azure. And for that, I have done something that's a bit different. So last week, we did the Docker Compose thing, and I showed you how that worked. And I showed you that in this particular case, you can see that I'm actually injecting that war file into the Jetty container. So the Jetty container spins up, and that war file gets injected. It gets injected as root.war, and that's how. And basically the container will see that and start running it. Okay, that's what I showed you last week. Now the question is, we're going to have a container running in the cloud, and we're going to be wanting to update that container regularly in different ways. Now you could just create a new Docker container and just post that up to the cloud. That would be one way of doing it. But the other way of doing it is to say, well, why can I not just post that war file into my running Jetty? If I've got Jetty running up there, maybe it'd be possible for me just to push a new war file into that Jetty, and the Jetty will discover it and start serving up the new war file. Well, that's what you could do. And that is what I'm going to show you how we can do. So what I've got here in this case is a slightly different Docker Compose file. And you can see that it's basically exposing ports, but it doesn't actually have the name of an image. What it has is this build and a dot. What that build and dot is doing is saying, I want to build this Docker file. And the Docker file is starting from the image we were working with before, which was Jetty, but it's extending that image by going and downloading this cargo Jetty deployer file and installing it into the application at a known place. Okay. So what I'm doing here is I'm creating a new image, which Docker is going to run, that's going to include this file that is got this deployer in it. All right. Now, if I show you that running, he says, so first of all, I've got to, I'm going to just make sure it's down before I do anything else. Okay. So I need to build this application first of all. So the first thing I'm going to do is Maven clean install, right? And, this will just do its build and it'll be happy. Okay, and it's built the war. The war is there to be used. Now, I could just run this up like I did last week using Maven Spring Boot run, which will just run it locally, and we'll see it coming up in a sec. So that's, registered the app, starting it up. You can see various things about creating database points and injecting them and stuff like that. And if I go to, localhost. There we are. That's the app running. Okay, so that's just running using Maven. Okay. Now what I'm going to do is run it in Docker, but I'm going to start by deploying it. So what I'm going to do is I'm going to run this Docker Compose deploy file, right? Not down, up. And I'm running it as a, actually I won't run it as a daemon because I want you to see what's going on. So I'm going to run that as a up. So again, it's created, it's installed that image, right? And now what I can do on a separate thing is I can actually, sorry, scrap all that. I'll take all that out of the tape because actually this is what I really wanted to do. So there's a thing I need to do. This build is the first thing I need to do. So I needed to do the Maven clean install stuff, then this build, and you'll see when it's doing the build, what it's actually doing is running that. This here stuff you can see here is actually the Docker command that's running to actually build the image. So I've built the image, and now I'm just going to run it. And I'm not going to run it as a daemon. So there we are. So that's running. So if I go to my web page now, just click on that, you can see there's nothing there. But what there is this cargo jetty deployer, which if I click on it, it just says command is unknown. So it's actually a REST API, and it would be expecting me to send a command to it, but it's not. So that means it's running. It is there. How do I deploy to it? Well, again, I do some magic. Maven cargo deploy. And what it's going to do is it's going to send that WAR file up to my server. And you can see it's thinking about it. The server actually, you can see it's actually received stuff and it's now spinning up. So I've now deployed that WAR file to that remote server. And my Maven command is finished. The thing is deployed. And if I go back to this now and go to 8080, you'll see my applications there. Okay. So does that make sense? What I've done is I've made a Jetty server that can run in Azure, and I can deploy to that Jetty server using Cargo, which is this application. And in the Maven repo, again, if I look at the Maven file for this, come on. We go right down to the bottom, you'll see all the cargo stuff, right? So that's the cargo plugin that does the deployment, and that tells it the address, the username, the protocol, and the password. All right. Now, I have not set up any security, so you're going to have to look at the cargo documentation to work out how to do this securely, because there isn't any at the moment. But the point is that once you've got this stuff running in Azure, you can deploy your WAR file to it as and when you want to. Does that make sense? Right. And I've got all the recipe there for you to do that, but you're going to have to do more homework because the problem is it's not secure. So to make it secure, you're going to have HTTPS, for which you're going to have Nginx installed. So that'll be next week's little problem. But you can go and look at the documentation for that. I do have examples in here, which you can see for Nginx. Just look at the README again. You go down the README, there's a load of stuff here and the different stuff. And then there's an example Nginx Let's Encrypt stuff here too, which again, you can go and have a look at if you want to understand. You are. Right. Okay. Any questions on that?
So if I understand correctly, the deploy essentially provides Jesse's REST API with what it needs.
Provides,
So
sorry.
Jesse's running on Azure, and that's essentially
Jetty,
yeah.
Jetty, yeah.
That's running on Azure, and it's sort of a REST API, so you need to send it something.
Yeah.
And a cargo build is configured to send it essentially the WAR file, which you then.
That's right. So Jetty needs a WAR file. You can manually place that WAR file in there, or you can send it. You could send it using FTP or something like that directly if you wanted. But this cargo is just a way of making the Jetty server able to receive a WAR file remotely, and easily publish it to that machine. So that means that when you're doing your build and stuff like that in GitHub, you could, as part of that build, you could actually deploy it then. You know, so that's where your CI/CD would come from. You build a thing, you deploy it, and it'll replace the old war with the new war, and magic will happen. Yes.
That's what we do our testing for, like, within the CI/CD pipeline.
So you need to do your testing within Maven in terms of well, there's two types of testing. There's the application testing to make sure the thing's actually up and running. And then there's the testing of the application to make sure it's compiled properly and, you know, all that. So integrate, you know, basic, simple sort of unit testing you'll do in Maven. How you actually test that your application is still running, you're going to have to think about that separately. Because what you've got to do is externally to that application, actually make some REST calls or make some page calls to that app and make sure that it's responding as you expect. Okay. Now there's services out there you can get, and you can get a free version of that service, and that will work. I think Datadog would be an example of that. You could probably try a free account with.
GitHub Action.
There might well be. So if that works for you, that's great. I mean, at the end of the day, you're just doing very simple.
Because Datadog in Grafana and stuff like that, like monitoring.
Yes, it is. But you're part of the assessment is monitoring as well. So you're going to have to be able to monitor your web app when it's up there and make sure the thing's still up. So yes, so Grafana and all of that you'd use to monitor the web app. But we're still at the point of creating the web app.
Baby steps.
Baby steps. But you see, in your team, you could have guys going off and looking at, I mean, you've got enough of a web app now to be able to do that monitoring. So you could actually have one of your folk in your team go off and say, well, how would I monitor this? And actually start doing that work, because if you can get it working for this, you'll get it working for the final application easily enough. Hello, time to go. Right. Any other questions? Okay, well, I'll stop the recording there. I'm sure there will be questions, but you know, we're there.